Good morning or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webcast. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our panelists, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your questions. And we'll try to get to as many as we can near the end of today's webinar. And also at the end of today's webinar, we will be doing a drawing for 3 $50 Amazon gift cards. So please stick around. Maybe you'll be one of our 3 lucky winners. All right, with that, we'll go ahead and kick off today's webinar, which is Beyond the Top 10, Finding Business Logic Flaws, Data Leakage, and Hard-Coded Secrets in Development. Our speaker today is no stranger to the DevOps.com webinars. Chetan Kaneki, who is CTO and co-founder of Shift Left. Welcome, Chetan. Thank you so much for joining me today.
Thank you, Charlene. Appreciate it. And very good morning, good evening, and good day to all the attendees and listeners. As Charlene mentioned, my name is Chetan Kaneki, and we have a very interesting topic to cover in the next 40 minutes an hour. And this topic focuses on looking beyond the top 10 and essentially taking a glance at the emerging threat landscape, which includes and not limited to business logic flaws, data leakage, and hard-coded secrets in development. To start with, web applications, SaaS-based or API-based, have become the most common means to provide services on the internet. They're used for mission-critical tasks and frequently handle sensitive user data. But as we all know, unfortunately, web applications are often implemented by developers with limited security skills, who often have to deal with time to market pressure and financial constraints. As a result, number of web application vulnerabilities and compliance violations have increased sharply. So in today's agenda, we're going to cover the following topics in sequence. Firstly, we'll take a look at sensitive data leaks, both from a compliance perspective and also from a violation perspective with the security lens. And then we'll move on to hard-coded secrets, which are not necessarily different from sensitive data leaks, given that both secrets and sensitive data leaks pose risk for compliance violation and data breaches. And then we'll move on to 2 following interesting and emerging threats, one being business logic flaws, which essentially does not subscribe to the normal types of vulnerabilities that OWASP has done an efficient job in categorizing. And finally, we'll close with insider threats. Every application that connects to the internet utilizes a data structure to represent their customers, typically when their customers sign up or perhaps log in within the scope of a session, and also a key or a secret in order to identify and authorize your customers to third-party services that your application is integrated with. These data elements and keys typically identify your customer session and the app or the project making a call to the API that you have authorized to connect your application to. And often, API keys give full access to every operation an API can perform, including writing new data, deleting existing data. And historically, developers have found several ways to store these critical data elements, which include your customer represented data and also keys that your application is using as third-party services. And often these critical elements, which represent both your customer and your infrastructure, are stored either in environment variables, which we'll talk about shortly, which is bad. In certain cases, they're stored in local databases or caches, which are also bad. And at worst, it's mistakenly embedded or hard-coded in your source code. The bad news is that you've just spread an important secret or PII data to every developer's computer or your source code controller or your source code management provider's storage and backup systems, and the risk of the secret leaking to public has increased exponentially. Of course, it's easy to put blame on your developers, but let's be honest. A full-time staff of security engineers couldn't possibly track down every leaking key or secret in a large code base comprising of 1 million lines. We are only human and accidents happen. So as security practitioners, our goal is to detect what type of incidents happen, prevent them from occurring in the future, and continuously educate our organizations about the importance of protecting the keys to our kingdom. So the first step is defining policies, applying these policies across your entire infrastructure, and measuring to ensure that these policies are not violated. As we spoke of earlier, the first step includes mapping out PII data in every microservice and legacy application comprising of your representation of software. The other is tracking how these critical elements are moving ingress and egress across your applications, meaning data received from the outside and dispatched outside after being transformed, obfuscated, redacted, etc. The other is continuous assessment of architectural constraints, meaning as security stewards or leads, your responsibility is to ensure that such data, which is marked as critical, is treated with utmost care. And then deletion procedures, because if you examine various compliance and regulatory institutions, they are mandating that a customer should have access and privilege to delete his or her identity from your system. So when they enforce a request for that deletion, it is important that you delete all representation of that customer in all of your subsystems. And finally, if a data breach happens, do you have an effective incident and response plan to address and mitigate? Let's start with the most difficult part of this exercise, which we call as the data mapping exercise. The symbol of record or the inventory is essentially your source code, your databases where you're essentially persisting all of your customer data. And as your application deals with that data, it is effectively collecting, processing, and transmitting that data through its course. So the automated data-driven process of answering these questions are critical, which is where and how do we collect personal information? Where are we storing this personal information? Because often when a customer signs up, we store the customer's identity in a database securely. Thereafter, we want to track the frequency at which the customer logs in, so we improve the experience of the customer, which means we land up using third-party click tracking services in order to track the customer's behavior in our infrastructure. How do we protect that personal information that we collect and store? And lastly, how do we prevent an inappropriate use of this information? Because often various departments in our organization, like sales and marketing, want to effectively use our customer information to target and cross-sell other product features to our customers. So let us zoom in and examine how a typical data structure representing our customer would look like. I'm going to use a Golang-based structure in order to draw this point, but it's not very different from any structure represented or written in any specific programming language like Java or Rust or Python, etc. What you see on the screen is a user-defined data type, which is person, that has attributes, name, age, city, and phone. Most or some of these attributes are sensitive from a personal identifiable information perspective. So the first step is to identify and quantify that this is sensitive, and thereafter we observe to see how it is being treated in your application. Often in object-oriented programming languages, we encapsulate behavior with the definition of the user-defined type as well. So the second step that we have to glance at is the behavior. meaning what are we doing with this data? Because as this data element is created, this data comes to life as a customer's login, where name, age, and city is populated with the customer actively interacting with your web application. And thereafter, we have to observe where is this data moving as it comes to life. Is it being persisted to a database? Are you transmitting this data to a third-party click tracking service, etc.? So as a part of this data mapping exercise, the important thing is to mark this data element as sensitive. And in order to accurately do this marking, what we have to do is extract sensitive terms and names, which already have been populated in various regulatory and compliance institutions like SOC 1, SOC 2, HIPAA, GDPR, CCPA, IBAN, etc. What these different regulatory bodies have done is provided guidance of various terms that are deemed sensitive. And these terms could be sprinkled in your databases, in your source code, etc. So the first call of act is, as we analyze your code, we look at your user-defined types, your variables, and mark these elements as sensitive. The second step after marking them as sensitive is to follow these objects when they come alive and represent your customers to see where exactly are they moving in your application. And as they move through your application, it is important to identify that they are not leaking outside the crevice of your application. Switching context, we looked at user-defined types in the prior slide. Now we're going to look at secrets and credentials and tokens that represent various APIs that your applications are using. As we spoke of earlier, engineers often mistakenly hard-code credentials in source code. And what you see on screen is an excellent example of your AWS access key and secret key hard-coded in the code. This often happens. And the next affirmative step for an engineer is detect this and move this either to an environment variable or perhaps to a configuration file. But yet, if you observe the behavior, if this critical pieces of data are logged in clear text, then that log data is indexed by your logging, single pane of glass like Splunk and Sumo Logic and ArcSight, etc. And then again, these data elements are leaked. So it is important to observe these data elements and ensure that as these data elements are hard-coded, initialized in your code base, it is appropriately encrypted, obfuscated, or redacted before it flows out of your application. So if we summarize and zoom out, we spoke of user-defined types, we spoke of secrets that are often created in your applications that are servicing your customer. So as we build a system, it is important to quantify what is a secret, what is PII as the first step, which is the data mapping exercise. The second step is to observe how these data elements are flowing through your application to end units like database, APIs, log aggregators, third-party SaaS services. And in order to finally ensure that your application stays compliant, these data elements should be encrypted, redacted, and obfuscated so that none of these elements can be reconstructed in an event of a data breach. Let us examine a case file. Not too long ago, that is May 3rd, 2018, Twitter sent an advisory to its 330 million users at that point to change their password after a bug exposed all of their passwords in plain text. Now, this is a classic example of a mistake committed by the engineer of logging passwords in clear text to the log file that got indexed, aggregated, and placed in the dashboard of a typical log aggregation provider, which actually means all the administrators had clear text view of all the users. Again, this is a mistake that all of us are subject to. So it is important for us to apply necessary instruments to measure our security posture from the perspective of both sensitive data and secrets. Now let us switch our lens and look at a different category, which is business logic flaws. The vulnerabilities in web applications are broadly classified into two categories. Vulnerabilities that have common characteristics across various applications and vulnerabilities that are application specific. Majority of the commercial tools in vulnerability analysis sectors have focused on identifying and mitigating input validation flaws. These class of vulnerabilities is characterized by the fact that the web application accepts external input as a part of its sensitive operation without checking and sanitizing it properly. Prominent examples of input validation flaws are cross-site scripting, SQL injection, etc. And case in point of SQL injection is an attacker provides a malicious input that alters the intended meaning of a database query. One reason for prior focus of input validation vulnerabilities is that it's possible to provide a concise and a general specification that applies across all applications, albeit any application operating in different domains like finance, insurance, healthcare, etc. That is, given a programming environment, it's possible to specify a set of functions. That is, typically in your code, you have a set of functions that read inputs. They're often called as sources. A set of functions that represent security sensitive functions that are called as sinks. And finally, a set of functions that check for malicious content that is reachable from source to sink. Various static and dynamic analysis tools can be applied to measure for common vulnerabilities that I'm speaking of, which is these generic vulnerabilities that apply across various domains. But it's relatively hard to examine and identify this emerging flaw, what we call as business logic flaws, where we look for vulnerabilities that result from errors in the logic of the application. Note, I'll emphasize on the word logic, because in every business domain, you're building applications that have a specific logic. If you're speaking of insurance, the logic is accepting a claim and then applying necessary workflow on that claim to address that insurance claim. When we speak of a payment system, it is about authorizing a transaction and capturing a transaction and fulfilling a transaction. So note that there is business logic across all of these domains that are specific to each of these domains. And often business logic flaws are flaws that an attacker can use to bypass or sidestep a certain workflow in order to abuse your application. And most of the time, they're looking at abusing your application in order to take advantage of either the transactional system or eventually exfiltrate data from your application. So if you pay attention to both these diagrams, in simplistic terms, what I've done is represented a typical vulnerability as a straight line. Because what we're doing is quantifying a source, which could be a web route that is accepting external input. Then your next step is authorization, validation, and then you touch a security sensitive function, which could be a database, or perhaps reflect the results back to your web page, or communicate with a third-party service. But if you pay attention to the diagram below, the very subtle difference between vulnerability and a business logic flaw is an attacker using heuristics and intelligence to first identify the characterization of your application by using intelligent tools like Burp, Zap, Metasploit, and then going ahead and figuring out ways to alter your attributes and bypass or sidestep a particular function in your application. Now note that I earlier mentioned that business logic flaws are hard to find and they're very specific to business domains. But I also will claim that there are certain common characteristics across business domains that can be quantified and analyzed to identify whether they can be sidestepped. And some of these common logic flaws are your password recovery system that fails insecurely, or a badly defined trust boundary, a poor password requirement where you effectively are not doing two-factor authentication, an insufficient process validation, a weak encryption scheme that you're using, or perhaps a bad error handling that you also have in your source code. So logic flaws encompass a range of vulnerabilities relating to privilege manipulation and transaction control manipulation, or a certain bypass of sequences or steps that we spoke of. Now, OWASP is also working hard to define and categorize these vulnerabilities, because this emerging landscape is essentially becoming more and more relevant right now, because necessary controls for OWASP common types of vulnerabilities are being placed, because we as diligent organizations are using firewalls, runtime application security protection, static scanners, etc. But where our blind spot lies is in categorization associated with business logic flaws, which is why OWASP has begun this journey, which is great. And if you notice, these categories are fairly confusing at this point, but give it a year or two, it will become more descriptive and relevant. But if you pay attention to some of them, they're essentially speaking of authorization security, business process out of order, business data tampering, etc. So given that we spoke of business logic flaws, let's use a simple example to understand how someone can bypass or sidestep a particular workflow in your application. This diagram is a very simple diagram that is describing how an attacker might interact with your application that might be using a payments provider like PayPal, Stripe, or any one of these very popular payment providers. If you have a storefront, which means that you have an e-commerce website, it's obvious that you provide your customers the facility to shop for items, add these items to a basket, and eventually check out. And at that point, you are transferred to your payments provider, where you add your user ID and password, and thereafter the transaction is fulfilled. So if you switch context and examine how an attacker might interact with the system, let us examine the first axis out here and follow the 1, 2, 3, 4, which I'll shortly explain. The first step is the attacker logs in, adds one or more items to the basket. Often these items will be low-priced items. And eventually your system will create a unique token to represent your customer's transaction. Now, after this attacker representing or masquerading as your customer completes the transaction, he or she is directed to the payments provider. That could be Stripe, PayPal, or any other payments provider. And after that, your system, depending on your business logic, will take this unique token, send it to that payments provider with the transaction, the cumulative transaction amount, and then authorize that transaction to say that, are you a legitimate user? You've fulfilled your transaction. Now, if your credit balance is sufficiently good, the payments provider will return a payment ID, which is another unique representation of this transaction to you. So what the typical attacker will do is intercept this particular transaction through a tool like Burp or Zap. And if the token and payment ID is exposed, what they will do is capture this payment ID, what has been marked as orange in this diagram. And thereafter, they will spin out another browser, initiate another session, log in, add more items at a higher price to their basket, and now reuse this token ID and payment ID and attempt to fulfill this transaction. So this is a very interesting way of sidestepping and essentially buying more items and paying less for it. Now, what I just described is just not a scenario. It happened not too long ago, and there is an active bug bounty system of record that is stored describing what just played out in my description. Now, let us pay attention to another business logic flaw, which is very interesting. This happened not too long ago with New Relic, and I have the source link of HackerOne, which essentially provides further detail associated with this flaw. Now, when we have any service that we provide to our customers, we band that service into different tiers like free tier, professional tier, platinum tier, etc. And each of these tiers are providing additional value-add services to our customers. In this scenario that played out with New Relic, what one of this consumer did was register with New Relic free service, intercepted the request, and began to observe what are the attributes that actually represent the free service. And it so happened that mistakenly New Relic was exposing certain critical parameters that represented a particular tier, like user level and subscription level, as you see below. Now, what the attacker did thereafter is began to enumerate user level with different types of strings, like administrator, premium user, etc., and subscription level with professional, platinum, because these are common ways that you band or categorize or cluster different services you provide to a customer. And it so happened that after enumerating with few combinations and permutations, the attacker was able to avail professional service tier at the cost of free service, which means that they began to avail larger band of services at no cost. Now, this is again a classic mistake that we commit as engineers, because as typical request response happens, we begin to reflect back certain critical attributes. And as we reflect back, we are providing additional data for attackers to enumerate and figure out ways to bypass and sidestep our flow. Let's examine one more use case. This happened with Uber not too long ago, and the HackerOne URI is placed here for your additional reference. Now, typically when a rider requests for a ride, there's a workflow associated with it on our mobile phone, where the location is picked up, then the application begins to look for drivers that are available in the vicinity of this coordinate, and then the appropriate driver chooses to pick that ride, and then the transaction is fulfilled. In this case, the attacker intercepted the request and began to enumerate various fields exposed, and stumbled on one particular field called as payment profile UUID. And as typically an attacker would do, he or she began to enumerate this payment profile UUID with various permutations and combinations. And by essentially manipulating this particular value, the attacker was able to make the transaction disappear from both the driver's trip history and also the rider's history, and the transaction was fulfilled, which means this attacker was leveraging Uber to get free rides perpetually without paying a penny, and there was no history of this to refute or validate. Now, as we know, attackers spend a lot of time and heuristics examining your application and figuring out ways to bypass. But attackers are evolving too, and leveraging a lot of open source too. So here's an example of an attacker leveraging Burp Suite, loading up two plugins called as Autorize and Auto Repeater to intercept requests firstly, observe various attributes in the requests, and then using various open source contributed lists like FuzzDB and SecLists to enumerate these values, and then repeat that process over and over again till they receive feedback. And most of the time their feedback is a 200 OK, which tells them that there was no error, the system reciprocated or reflected back with a success, and that also implies that they have sorts of bypassed or achieved some degree of success that takes them to the next step. Now, finally, we're going to switch context, because we spoke of business logic flaws. It's an emerging threat landscape. And of course, we have to pay attention to this, because most of these scanners, our firewalls and our runtime protection systems are sorts of blind spotted to this emerging threat landscape. Now let us switch context and look at this very interesting other emerging threat landscape. And this is associated with insider threats and backdoors. Now, this is a risk associated with renegade software developers or consultants that we hire within the organization. In this case, typical employees go through ups and downs in the organization, or the organization perhaps in itself is going through ups and downs. So in this case, we are either terminating contracts with consultants, or if the company unfortunately goes through a financial upheaval, there is a layoff. And as a consequence, an engineer might turn into a renegade engineer. And in this case, they might plant or sabotage the system by placing a rootkit or a particular insider or backdoor in your code that would cause your application to constantly implode. And the reason to do this is just a malicious reason, meaning that they're not happy and they want to cause some degree of collateral damage to your organization. Now, these rootkits are fairly hard to detect because they don't fall within the symptoms of typical vulnerabilities. Because remember, we spoke of two types of vulnerabilities earlier, which is typical classic vulnerabilities categorized by OWASP, and then we spoke of business logic flaws. Now, as we spoke of vulnerabilities, we touched on the topic that attackers are influencing or trying to exploit your application from the outside, meaning they're using a source to touch a sensitive sink within your application and triggering either a cross-site scripting, a deserialization attack, or a SQL injection. With business logic flaws, we spoke of how an attacker is carefully understanding your application, applying heuristics, and then sidestepping a business logic in your application. Now, with insider threats, both those cases don't hold water, because what the insider is attempting to do is placing some code inside your application, masquerading or obfuscating that code so that it escapes typical code reviews, and then it is going to implode at a certain scheduled interval or when a certain event is triggered upon your application. Now, typical attackers go, or insiders go through various degrees to hide their code. Because, often when you're sustaining through millions of lines of code in your application, either albeit legacy or microservice, the degree of precision associated with code review begins to drop over a period of time, because engineers are not incentivized as much for code review. So they don't pay as careful attention to examining whether this certain piece of code that is base64 encoded or masqueraded somewhere that looks suspicious. So what an insider might do is, over a period of time, add several patches and check-ins that when they collectively form together, it becomes a threat. So here's an example of a particular rootkit called as the Wabbit virus or a folk bomb that was discovered not too long ago in a particular institution. This was placed by a renegade or an insider or renegade developer because they were not happy with the organization, and they at a point felt that they're going to be losing their job. So this Wabbit virus is nothing but a logic bomb. The logic bomb is just these series of expressions that you see below, which is backgrounded in green. And when base64 encoded single time, it essentially looks like this random string. Now, an attacker or an insider could essentially just base64 encode it once or several times, or choose another redaction or obfuscation scheme and implant that in your code. And perhaps at a particular scheduled interval, can choose to decode it or deobfuscate it and then execute it. Now, note that both of these are separate patterns that might exist in your source code that bear no connection. But when these patterns happen together at that scheduled interval or when an event is triggered, it would constantly cause your application to restart, because this leads to kernel panic, and this kernel panic is essentially triggering your kernel to not cope and landing for a continuous crash of your system. So often your DevOps system will continuously restart it, and then if this event again is triggered, it will cause the system to collapse. So this is a real life case of a virus placed by an insider. And also, they're not just one case, but there's several cases. And I have listed these cases in a blog article. If you reference medium/Koniki, you will find a series of articles that I've written where I talk about all of these cases that have happened, particularly with financial institutions, which are more regulated. And at the same time, all of these cases sorts of have common patterns as well that can be detected and identified for. So we spoke of business logic, sensitive data leak from a compliance perspective. We spoke of insider threats. We sorts of drew a distinction between common vulnerabilities that stand apart from these other three categories that we spoke of. So as security engineers and AppSec engineers and any organization that's writing software, it is important that we constantly stay on top of monitoring and identifying for such issues that might exist in our system. So we at Shift Left have built a system that enables you as a customer to constantly identify and measure for any patch that is applied to your source code management system that might manifest as either a push or a pull request. So we provide a very simple integration that seamlessly integrates into your Git ops, if you're either using GitHub, Bitbucket, or private Git. With a simple command, you can establish connectivity into all of your source code repositories. And every time any engineer creates a pull request, the Shift Left analyzer runs to measure for common vulnerabilities, business logic flaws, leaking secrets and sensitive data, insider threats. And if we happen to identify any violations, we provide necessary controls to you as a security organization to fail that build. And after that build is failed, we provide a hyperlink to your dashboard where you can get further details associated with the type of vulnerability that we discovered, with all necessary metadata associated with that vulnerability, meaning what was that release that seeded the vulnerability, and did it exist in the prior release or not, and what can be done to mitigate from that vulnerability. Now, we are acting as your security engineer by constantly monitoring every release of your application and letting you stay on top of your compliance and your security risks. With this, I'd like to close the presentation, and I would like to encourage you to visit www.shiftleft.io, set up your free account, upload your workload, and experience the product for yourself. And through this journey of the trial, we are happy to help you understand the product and improve your security posture as an organization. Thank you very much, and I'm happy to take questions at this point.
All right, great. Thanks, Chetan. If you have a question, please go ahead and use your GoToWebinar control panel. And doesn't look like we actually have any questions in yet, so we'll go ahead and see if we do get a couple in. And while we're waiting, I just want to remind the audience about the fact that today's event is being recorded. So if you missed any of the presentation or all of the presentation, or if you just want to listen to it again, you will have the opportunity to do so. After today's webinar, we're going to be sending out an email that contains a link to access the webinar on demand. So you can always check your email for it, but you can also always go to devops.com because it will be living there also. Just go to devops.com/webinars, look in the on-demand section, and it'll be right there waiting for you. Let's see. Well, actually, we do have one quick question for you here. Is Shift Left going to have a booth at RSA in San Francisco?
We are definitely going to be at RSA. We have a suite where we will be taking more personal interviews and presentations and trials with some of our customers. So feel free to reach out on our website, register, and we can schedule a one-on-one meeting with you to give you further detail. And I will also be presenting a very detailed study on business logic flaws at RSA. And just visit RSA, Google my name, Chetan Koniki, and you will get further information off the track that I'm going to be presenting out there too.
Awesome. All right, great. We have another question here for you. Can the sensitive customer information kept in employees' emails be associated with insider threats?
Absolutely. I mean, for the first part, we have a system that can detect and let you know whether key pieces of information are being placed in email subjects or text in plain text. Now, this could be a compliance violation from a category perspective, and at the same time, an insider employee might land up doing that too if you don't have sufficient measures and controls in your system. So the answer is yes, we can detect that.
Okay, all right, great. Next question here. Does it work for C# code and ASP.NET?
Yes. So currently Shift Left supports Java, Scala, Golang, C# .NET, JavaScript, and we'll soon support Python, LLVM, and Rust.
All right, let's see. Great. Okay, guys, got a question? Please go ahead and use your GoToWebinar control panel and submit it. We do have time for a couple more, so if you've got any burning questions, now would be the time. Let's see. Chetan, what?
Yeah, please go ahead.
I was just going to say, what day? Do you know what day you're giving your presentation at RSA? Just so folks can know.
Thursday the 26th, I presume. Thursday of the week after next.
Okay, all right, great. We do have another question that just came in. Great presentation, so congratulations there. Please comment on highlights of product features regarding compliance, especially GDPR, CCPA, and PCI.
Thank you for the question. It's a great question. You know, often each of these compliance and regulatory institutions define legalese that describes what you need to do to ensure that you stay on top of a specific compliance. You know, GDPR is focused on data exchange between different continents. CCPA is specific to California. PCI has a broader umbrella. So what we have done at Shift Left is examined all of these compliances, extracted terms that each of these compliances deem as sensitive, and then examine your code to match against these terms. And thereafter take certain legalese that have been described in each of these compliance and then fit it into a report to let you know whether you are in compliant or violating that specific compliance. So usually when you're measuring yourself for compliance, often in the past you would have, or currently you use spreadsheets where you ask a specific question with the choice of a yes, no, and maybe. And often most of the folks use maybe in order to stay vague. But here is a way you can actually drive everything using data so that there's degree of certainty of whether someone is adhering to compliance or violating a particular compliance.
All right, great. We have a comment here, not exactly a question, but I feel the need to tell you. It says, not a question, just a shout out for this excellent webinar. Being fruitful indeed to stay up late at night and watch this according to my IST. So it sounds like you hit the nail on the head for this particular viewer. So thanks for that great comment.
Thank you, Abhishek. Thanks for staying up late. Appreciate it.
All right, great. Well, guys, I'm going to do about 2 more minutes for the question and answer period. And if we don't get any more in, we'll go ahead and close it out. But also want to remind the folks that Chetan has done a couple other webinars with us before, and they've all been this caliber or higher. So please, I encourage you to go to the DevOps.com website and look in the on-demand section of the webinars for the other Shift Left webinars that have been done. They are definitely worth checking out. So, let's see, got another thanks and another thanks for the presentation, no questions. So I think everybody's pretty much tapped on the questions, Chetan. So I think I'm going to go ahead and, oh wait, nope, we just got one more and I knew that was going to happen. So next question here, what are the different hard-coded secrets scenarios?
Excellent question. You know, typically often firstly we spoke of data. You know, when we spoke of user-defined types, where, you know, if you're using an object-oriented programming language, you say class user class customer, etc. But when we speak of hard-coded secrets, secrets could be associated with your infrastructure, meaning if you're using AWS, Azure, or GCP, you might have an access ID and token. If you happen to be using Stripe, PayPal, or any other payments provider, you might have tokens representing that as well. Now, every time your application interacts with a third-party service that you're leveraging in order to provide value to your customer, you often use credentials, and these credentials are actually secrets in itself. Now, if for some reason you hard code these critical elements in your code, and if you don't rotate these credentials, then if that code gets exposed in your source code, in your log aggregators, then what you run the risk at is someone taking your credentials and using it for their own purpose, meaning using your cloud credentials to do Bitcoin or crypto mining, or perhaps at some point you wake up and you realize that your cloud bills have exponentially increased because someone is using your system because the keys were exposed and you didn't do a good job in rotating those keys. So hard-coded secrets come in different forms. What we have done is extracted various, almost we have like 2,000 to 3,000 representations of secrets, not just limited to infrastructure, but also bank account numbers, telephone numbers, social security numbers, etc. And we have the ability to detect all of this and let you know that you have a system that's violating your compliance.
All right, great. We actually did have a couple more questions come in. So the next question is the only way to use shift left over SAST, or can it be implemented on-prem?
Currently, shift left operates using a SaaS service, meaning that we are hosted in a cloud and we provide you the ability to upload your workload securely to a cloud. Now note that that does not mean your sensitive data is coming to a cloud, because what our technology does is it computes a representation of your code, which is what we call as code property graph. It's a graphical representation of your code, which is very proprietary, secure, and encrypted. And that representation is uploaded to your account in our cloud. And let me emphasize, it's not your source code, but it's a graph representation of your source code. And given it's a binary protocol, no one can make any sense of it, even if they open it, given that it's obfuscated, encrypted, and it's in binary form. So we also do have an option for a product called as Ocular, which can be installed on-prem. But if you want the efficiency of integrating into your CI system, which is GitHub, GitLab, Bitbucket, we recommend going with the shift left SaaS platform.
All right, great. Let's see, we do have another question here, which you actually just answered the first part, which is, do you store our source codes? But the second question is, would our source be read by human or machine code, NLP, etc.? So
the source, like I answered the first part in the prior question, we do not store your source code. We have built a proprietary technology called as code property graph. If you Google these three words, you'll get sufficient information from academia about what it means. Again, very quickly, on your build box, we analyze your code, we convert it to a graph, and this graph is in binary protocol format, which we further apply obfuscation techniques and encryption techniques to, specific with your keys as a customer. Now, as we receive this graph, we apply a series of automated models that have been derived using machine learning, statistics, and heuristics in order to extract vulnerabilities. So there's no human equation as a part of this process. I want to emphasize on that point.
All right, great. Okay, next question. All of a sudden we've got more questions in. The next generation code analysis is a broad name. How is this different than a SAST, DAST, or IAST tool?
Great question. We use the term next generation, and if I try to describe next generation, I'm not going to sound like a marketing person because I'm not. I'm an engineer by profession. So I'll give you a very appropriate definition. We call ourselves next generation because we founded the company in 2017, which means that we had the opportunity to examine how the new world of software looks like. Because in the traditional world, we wrote software, typically which was deemed as legacy software, which was a very large service, deployed that service in a servlet container or any other container, and provisioned it in our private data center. Now, if you reset and look at how software manufacturing is evolved, you have engineers today using various modern programming languages, building microservices, using chassis like Kubernetes, Mesosphere, and serverless units, and deploying in the cloud. So given that we had the opportunity to be born in 2017 as a company, we said, how can we build a system that is more relevant to this new world? Because in this new world, you're not going to be spending time or hours analyzing your software for security, because your build system takes minutes to build and seconds to deploy into your cloud. So of course, you need a security solution that can analyze your workloads in minutes and seconds. So this is where we call ourselves next generation, because we can analyze your code in a matter of minutes and then tell you very quickly whether it has risks associated with it and influence your decision to be deployed in the cloud.
All right, great. I think we have time for one, maybe two more questions here. Here's one. Can you give some best practices in managing database secrets and credentials?
So best practice number one is use shift left to find whether someone has embedded secrets in your code. That's your data mapping exercise. As soon as you do, the next step is recommend to the engineers to use secure systems like HashiCorp Vault or Amazon or KMS, which is key managers, because these systems provide necessary instruments to ensure that all your credentials are placed in one appropriate place and necessary safeguards are applied upon it. The second step is rotate those credentials, because you always assume anything can be compromised. But if you rotate your credentials at a regular or an irregular cadence, it would imply that an attacker can exfiltrate data only to a certain extent. After that, if your passwords change, then they cannot move further. So the three best practices. The first is use a solution like shift left to find sensitive data and ensure that it's within compliance. The second is store that data in an effective place like Vault or KMS, or which is key manager. And the third is rotate your keys as often as possible.
Excellent, excellent. Okay, I think that is actually the last question that we have in, so good timing there. I do want to thank everybody who did submit questions. There were some really good ones there. So thanks again. And also wanted to remind the audience one more time that today's event has been recorded. So you will have the opportunity to access it later on if you missed any or all of it, or if you just want to access it again. It's also going to be living on the devops.com website. As I said earlier, just go to the devops.com homepage /webinars, look in the on-demand section, and it will be right there. So that will be in addition to the email that we send out with a link to access the webinar. Before we close things out, I do want to do the drawing for the 3 Amazon gift cards. So without further ado, our winners today are David K. Congratulations, David. Jeff W. Congratulations, Jeff. And Mark S. Congratulations to all 3 of you. And we'll be catching up with you by email to get the information regarding your gift card over to you. Chetan, thanks so much for such a great presentation. Really appreciate it.
Thank you very much, and stay secure all.
Yeah, well, I know the audience got a lot out of it, judging from the questions that came in and the comments that came over. So thanks again. And I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.